So our model 2 will actually use, in our model 2, we'll actually use ReLU instead of sigmoid, except that no major change, right? We'll use ReLU units, ReLU activations. My output is anyway going to be sigmoid because it's a softmax classifier. My input is the same. So we are not changing the sizes anywhere. We're still keeping the 784, 512, 128, and 10 as is. We are just changing my hidden layer 1 and hidden layer 2 activations to ReLU instead of sigmoid, right? So there is only one change here. The big change here is instead of using sigmoid here, we are using ReLU. Instead of sigmoid, we are using ReLU. This is the only two lines of code that change from the previous one. So in the function, we are calling it as multi-layer perceptron ReLU instead of just multi-layer perceptron. That's the only code change as compared to the previous section that we have seen. Now, again, we'll use Adam optimizer, all the same code, exactly the same code, right? There is one difference here, which is that we are using multi-layer perceptron underscore ReLU because that's a function that we have used to define a ReLU based model, right? So key thing here, very, very important thing here is this loss. Okay, first thing. So let's look at this value. What is a test loss? 1.48. Okay, so let's write it down. So when I use ReLU plus Adam, so ReLU plus Adam, I'm again getting 1.48. And what is my accuracy? 97.85. Right? So if you notice, what's happening here is, now let's compare these two. Let's compare these two. Okay? Because that's a fair comparison. So this is Adam and this is Adam. Both cases, we have this architecture is the same. We have run it only for 15 epochs in both cases. The only difference here is that here we have sigmoid, here we have ReLU. Right? But at the end of it, they both tend to give the same value. Remember, MNIST, the dataset that we are using, is a very, very simple and easy problem. When you have more very, very complex problems, you will see a significant difference in significant advantage in ReLU over sigmoid, right? MNIST is one of the simplest cases. That's why you may see some of the cases where we learned theoretically that we learned ReLU should perform because everything else is the same. ReLU should perform better than sigmoid. But in practice, because MNIST is a very, very simple data set, it's not as complex as, let's say, image-based object recognition. More complex problems or detecting cancer in images and things like that. It's not that complex. It's a very, very simple data set. And hence, you may not notice significant difference between sigmoid and ReLU. Okay, number one. But I'll show you something very interesting here, right? So next step is, okay, next step, let's go. Let's use SGD. Okay, weights checking, all of that basic stuff. Okay, now when I use, see here, what do I have? Here I have, okay, let me just scroll up a little more. Yes, here I have my ReLU based activations with gradient descent. Okay, so let me write it down. My fourth one, my second model is basically ReLU plus SGD. If you recall, this SGD, without any decay of learning rate, this performed really, really bad. What happens with ReLU plus SGD? See here again, between these two, now let's compare between these two. Let me change the color here. This is SGD, this is SGD, same 15 epochs. This is sigmoid, but this is ReLU. So I'm comparing these two now. I'm comparing these two because it's a nice apples to apples comparison, right? Right? The only change between this model and this model is sigmoid to ReLU. Everything else is the same. The optimizer is SGD, the optimizer is SGD. Okay, now let's look it up. The value that I get here is 1.823. Okay, so let me write it down. It's 1.823. And the accuracy that I get here is 10.66%. Now, if you notice, this is the fun part. If you notice, by just changing, see, I kept my SGD same. Okay, I just changed from sigmoid to ReLU. By just changing from sigmoid to ReLU in 15 epochs, I kept the same number of epochs. My multi-class log loss has reduced from 2.29 to 1.83. This is a significant reduction. While there is some improvement in the accuracy also. So while in the previous case, because Adam optimizer is super powerful, going from sigmoid to ReLU did not make a big difference between these two. But when you have a weak optimizer like SGD without learning decay, going from sigmoid to ReLU made an impact in my multi-class log loss. Right? Lower the better, right? In multi-class log loss. Even in accuracy, there is a small improvement. So this, I just wanted to run this because ReLU certainly is powerful. Even in this case, if my data set was not MNIST, but a slightly more complex data set, ReLU always does better than SigMoid because it has no issues of vanishing gradient, not significant issues of vanishing gradient, as we've discussed theoretically. So I wanted to show you this, and hence we have run both these models. Very, very interesting example. Now, just standard weight checks, all of that. The weights are not too large, not too small, everything is sensible, right? So I typically plot this to ensure, to get a sense of the distribution of weights at the end of my, at the end of training, right? So next model, we'll see what happens if we use batch normalization, okay? So again, remember, MNIST is a very simple data set, so you may not find significant improvement because of complex ideas like ReLU, batch normalization, and dropouts. Not significant. You'll see some value, but not significant value.